In this video, I'm showing how you can use a YouTube video to answer a question you might have gotten from students or to just give another resource for students to learn a concept. Now, I want to point out a couple things I've done. I've put a couple of booklets underneath this clipboard in order to raise the height of the clipboard so that it matches the screen of the calculator. Because you're going to have to pick a focal length for your webcam, and one or the other will be quite blurry if you don't take care to get your paper pretty much the exact same height as the screen. So, but looking okay to me here. So the problem I'm going to show, and obviously you could do any problem you wanted, x e to the negative 0.3x dx, the integral, the indefinite integral, and then actually a definite integral using the same thing. So, and this is of course, by hand we're going to use integration by parts. The integral of uv prime equals uv minus the integral of vu prime. So I need to make some choices, and I have to pick u and v prime, so that I have this integral represented by these two pieces here. So I'm going to let u equal x and v prime equal e to the negative 0.3x dx. So u times v prime is the entire amount under there. And so obviously you could have chosen the other way around, and it won't be wrong. It just won't get you towards an answer. But for quickness sake, I'm going to go ahead and just make the easy and the right choice quickly here. So v would be equal to the integral of that, of course. And then we actually integrate that, e to the negative 0.3x, and we get e to the negative 0.3x over negative 0.3. And so now I can use this formula to write another version of the integral. And of course the hope is that this integral will be simpler than the one we started with. So the integral of uv prime is equal to u times v. So x times this answer minus the integral of v, this one here, times u prime, which is just dx. So e to the negative 0.3x over negative 0.3 dx. It is a simpler integral. It's just e to a number. The constant can come outside. So we would have plus 1 over 0.3. The integral of e to the 0.3x is going to be e to the negative 0.3x over negative 0.3 again. And copying this down, plus a constant, and down to simplification, we're basically there. So 1 divided by negative 0.3 will equal, and this is actually the exact same thing as this integral we started with. 1 divided by negative 0.3, of course, is going to be negative 3.333, however many you feel you need for accuracy, x e to the negative 0.3x. And here we're going to have 1 divided by negative 0.9, so it might be helpful to actually do that on the calculator. 1 divided by negative 0.09. Negative 11.11. So that's these constants here. However many of those ones you feel you need for accuracy. You can negative 0.3x, or you can keep it as fractions if you really needed a perfect answer. And we could factor the e to the negative 0.3x out. So we would have negative 3.333 repeating forever, x minus 11.111 repeating forever as well, plus a constant. Now, reminding students that we could use the fundamental theorem of calculus. We would actually simply want to evaluate this thing for the second question. We want to evaluate it from 0 to 7. So plug in 7 for each of those x's, plug in 0, and you'd subtract. Okay, so I'm not going to bore my audience with the rest of that today, but I want to show how well this also can show up on the calculator. So I can do two different ways I can do this. For the definite integral, I can put y equals. I've already graphed it. So there's a picture of my graph. And now I can actually integrate it by doing second calc. Integrate. Lower limit is 0. Upper limit is 7. It'll actually shade in the region it's doing, give me the answer of 6.893. Now actually on the TI-83, there's another way of doing it nowadays. I can go to math, and if I go to the bottom here, I end up with integrate, and it does it in a pretty form, just like we're used to seeing integrals. So 0, and I'll put a 7 up there, integral from 0 to 7, x times x times e to the negative 0.3x dx. And if I hit enter, it'll integrate in a pretty version as well. Hopefully it'd agree with my other integral. And naturally, that should be the same answer I get plugging in 7s and 0s here as well. So what we've seen is the ease we can do a handwritten problem, also showing calculator steps. When I've tried to communicate with students through email and I try and write them, oh, this is how you would do something, these are the buttons you push on the calculator, I find that communication extremely difficult to do over email and even pretty difficult to do over the phone, but extremely easy to record on a video. And a lot of times you'll get a similar question from 1 or 2 students in a class. And this way you can answer it for the entire class and say, hey, here's a new video on some questions I've gotten you might want to look at. And many other students who have the same question then can access this, put it on your playlist, and it'll be there forever.